got some more of these reactions where you have to decide Sn1, Sn2, E1, E2, that kind of thing. And we've got a couple tricky ones in here, so that should make it fun. Alright, so let's try the top one. First of all, you see, okay, here are two potential leaving groups. Fluorine's a bad leaving group, but bromine's a good one. So we don't expect fluorine to move. It's a secondary, so it could do anything. But we have Cn-, which is a good nucleophile. Na+, that's just going to be your spectator ion. So Cn-, good nucleophile, not a strong base. We're expecting Sn2. So you just want to remember with this Fisher projection, when you redraw it, to invert the configuration. So I'm going to keep F the same on the bottom, but on the top, I'm going to invert the configuration for the bromine. Not the bromine. The Cn. Cn, because bromine laughs and Cn replaces it. So this is an Sn2. Let me write that down. Sn2. Okay, let's move on to the second one. In the second case, we've got tertiary carbon surrounded by three different things with a chlorine, good leaving group. We've got an alcohol though, so that it's not a strong base, so that pushes us towards Sn1 or E1, but we've got a relatively high temperature above room temperature, so we're thinking the E1. So we're thinking elimination, and so we're just going to make a structure here with a double bond. So this structure looks like this if I redraw it here. It looks like that right now. If I take off the chlorine and eliminate one of these, I'm just going to put a double bond, say right there. Okay? So it's a propene. It's like a 2-methylpropene. Okay, so let's write that down. That was an E1. Okay. Now, let's go to the next one. I kind of got a little erased right here, but this is a carbon. Okay, this one's getting a little more tricky here. NaOH, and it's a secondary. It could do a substitution, definitely, but, so you might think Sn2 with a secondary, but it's kind of sterically hindered with that T-butyl group there. So we're not really thinking Sn2, we're more thinking E2, okay? So this is one equivalent, that's forcing us to pick one of the bromines. And here's the tricky part about this one, and if you ever have a ring, especially a cyclohexane, with some funky groups on there, you probably want to draw it out. So let me draw it out, so this is kind of our scratch work here. Okay, let's say that's our cyclohexane. You know that the hydrogen will be in the axial position, and the T-butyl group will be like that. It has to be in the equatorial because of steric hindrance. Okay, and so let's draw, oh, and did I forget, I think that was racemic. Let me just double check that I got that in the racemic. Oh no, it's, this is a wedge coming out at us. Okay. It's a wedge, sorry about that. So these two are cis and these two are trans. Okay, let's draw this bromine right there. I'm going to put a little brown star by it, asterisk. Okay, there's the bromine. That bromine I want to draw now, and remember they're trans. Okay, one's coming out towards you, one away from you. Well, here's how I do these. You know, these two have to be trans, they're pointed away from each other. So every time you move your finger one position, you switch. Okay, so there's another one. If we just try this, let's see if this works. So if these are trans, that would be cis. These two would be cis, then these two would be trans. Okay, that's a little trick to figure out what's what. So this bromine, I'll put the little asterisk by it, is in the correct position now. Now let's do the other one. These two are cis. Okay, so we've got these two positions here. There's one down, and there's one, kind of hard to draw here, but kind of like that. Okay. Now, For example, these two positions right here, those are trans for sure. Now, I move one finger. These would be cis. Okay? So that's what I want. I want the bromine to be in the cis position and the hydrogen to be in the trans, because these two are cis. So let's just double check. The two opposite pointed axial positions, right now, they're trans. Okay, I move my finger one. That's cis. That's exactly what I want. So if I just put a different symbol right here, a different kind of star, this bromine right here is that one. Okay, now, what the heck is going to happen here? We're thinking E2, again, because of steric hindrance. But remember, for E2, we need anti. Okay? Now, it could come in here, you might think. But again, this side's sterically hindered. So we're probably going to prefer this side over here. Because now, this bromine and that hydrogen are in the anti-position, which is what you need for the mechanism of the E2. Again, that one is anti, but it's pretty sterically hindered by the T-butyl. Remember, T-butyl's huge. So this is just my scratch work, not the final answer. So we're going to do an elimination, and just to draw an arrow here, the double bond is going to go right there. So we're doing an E2. I'll just draw it as they gave it to me, back like that, but that's where we're going to put the double bond. So the real answer would be this double bond. We've got our T-butyl still on the top, and we've got our wedged bromine on the left-hand side. And that's what I'm expecting for my final answer. The final E2 answer is right there. So again, when you have a cyclohexane, be careful. Okay, now here we go. Let's do the last one. This one's kind of a tricky one. You see this kind of stuff pop up every once in a while on a OChem test. You're thinking, oh wow, I've got a good leaving group right there. This is a secondary, but this kind of favors the Sn2 because it's so small. It can slide in there, a little bit sterically hindered, but this is a base, strong base, and so we got a base, and this hydrogen is acidic right there. Because that hydrogen's acidic, that base is just going to yank off the hydrogen. So it would look like this. Let me redraw it. It's just going to be basically the hydroxide group, but without the hydrogen. So it would be an O-. You might think, okay, it's kind of almost a no reaction. It's more of like an acid-base reaction. But now this is a strong base and good nucleophile. And we still got a good leaving group. So we can go like that, boom, and do an Sn2 attack. After that's removed, forming an epoxide. Freaky, I know. And so this will become an epoxide with both methyl groups in the forward position, or coming towards us, a wedge. Why? Because they started off in the forward position right there. And it's going to do a backside attack immediately. And so we come up with a product, even though we did an Sn2, because this has a mirror plane in the middle, this is not going to be optically active. It's inactive, but it's still a product. And there we go.